Just the dumb camera that's projecting up there. All right, section 4.4. All I have written on my little notes to help you with stuff is a bunch of examples again. So let's hit some examples and then we'll go through that list and to talk about the hints that some of the stuff we used in the examples. Okay, solve sine 2x equals sine x in the interval from 0 to 2 pi. So are we giving infinite answers? No, we're just doing just the answers from 0 to 2 pi. Okay, last time we learned about solving angles that have doubles or halves or stuff like that in them. But here's the problem. This problem has two different angles. If you're trying to find the numbers that make sine of an angle a certain number, if you have two different angles, is that going to affect your answer? Yeah. So on your list of hints, I believe there's one that says try to get everything in terms of one specific angle. Is there one that says that?
Yes, the first one says it.
Oh, perfect. So we don't want a double angle here and a single angle there. We want it to all be the same angle. Ooh, I guess we're going to have to use an identity maybe for this one. So far this stuff hasn't been too hard in chapter 4, right? It's been pretty good. This is the hardest section because we're putting a whole bunch of stuff together. Okay, so the identity for sine of 2x, very good if you have it memorized, is 2 sine x cosine x. Nice job. Now this brings us another problem though. Now, not do we just have sine, we also have a cosine in there. No, don't go that far. It's going to be fine. The hint in this problem is the title, Trig equations of quadratic type. Imagine that this is more like a quadratic that we're solving. So usually when we solve quadratics, which it's not, there's no x squareds or anything, but when we solve quadratics, don't we usually like to get everything on one side with 0 on the other side? So let's do that. 2 sine x cosine x minus sine x equals 0. Now we can look for common factors like we do with quadratics. Usually we look and see if there's something we can factor out. For example, if this was 2x squared minus x, we would be able to factor out an x, right?
Yeah.
Like if it was a quadratic from last term.
Yes.
Okay, so in this case, is there something we can factor out? Very good. Okay, so we can factor out sine, and that leaves us with 2 cosine x minus 0, right? I know sometimes I accidentally make mistakes, but I purposely did that one, honestly. Yeah. When you factor out a sine, it's not 0, it's 1. Okay, I just find students doing that. They think, oh, I factored it out, it's gone at 0. No, there's a 1 there. Okay. I'm sorry, maybe I tried a tactic that just ended up confusing you instead, so never mind, sorry. Okay, now if we were solving this like a quadratic, we would use what's called the zero product property, where we take each factor and we set each factor equal to 0 and solve it separately. How many factors do we have here? We have 2 different factors, and it just so happens that one of our factors is entirely sine and the other factor is entirely cosine, so we can just solve them separate from each other. Okay, so we have sine of x equals 0, and we have 2 cosine x minus 1 equals 0. So 2 separate problems to solve separately. So let's ignore that part of it. What values between 0 and 2 pi make this one true?
0.
Okay, 0 does. Is there anything else? Okay. 180 would not be correct because look at what interval it is. Since it says 0 to 2 pi, how do they expect you to give your answers? radians. So instead of telling me 180, pi is a much better answer. Thank you. Is there anything else between 0 and 2 pi? Well, 2 pi would be, but did you notice at the end of my interval what's there? It's a parenthesis, so we're not including 2 pi. So that would be it for this one. Okay. Now, cosine, what do we do to solve that one? Okay, it's a positive 1/2. What quadrants? So quadrant 1 and 4. That's where cosine is positive, right? So we need an answer in quadrant 1 and an answer in quadrant 4. Okay, what angle is cosine 1/2? 60 degrees, but in this case we want radians. Pi thirds. Okay, so x will equal pi thirds. And then fourth quadrant? If you go clear up to 6 pi thirds, that's 2 pi. So that can be right. Has to be 5 pi thirds in the fourth quadrant, right? So how many solutions are there to this particular problem? 0 pi, pi thirds, and 5 pi thirds. 4 solutions between 0 and 2 pi for this problem. Okay, I'm going to do